Alright, let's dive into something that's happening right now in Wales, and honestly, it's a big deal for the future of energy, not just in the UK, but globally. Here's the hook: imagine a machine that doesn't generate electricity itself, but instead acts like the steady hand of the power grid, keeping everything stable even when the system is hit with sudden changes. Sounds like something out of a sci-fi movie, right? Well, it's real, and it's called a synchronous condenser. And this week, one of these bad boys is going live at the Pembroke power station in Wales. Now, let me break this down for you. Traditionally, the stability of our electricity grid has relied on spinning generators in coal, gas, and nuclear power plants. These generators provide something called inertia, basically, the grid's ability to resist sudden changes in frequency. But here's the catch: as we shift to more renewable energy sources like wind and solar, those spinning generators are becoming less common. And that's a problem because renewables, as amazing as they are, don't naturally provide that same level of inertia. This is where the synchronous condenser comes in. It's like a specialized piece of tech designed to fill that gap. Personally, I think this is a brilliant example of how innovation is stepping up to meet the challenges of our energy transition. What makes this really interesting is that it's not just about keeping the lights on, it's about doing it in a way that's sustainable and future-proof. Now, let's talk about the bigger picture. The Pembroke machine is just the first of 16 new synchronous condensers being rolled out as part of the National Energy System Operators (NESO) Stability Pathfinder program. And get this, NESO estimates that these technologies could save consumers up to £9 billion in electricity system costs over the coming years. That's a massive number, and it raises a deeper question: how much could we save globally if we adopt similar solutions? One thing that immediately stands out is the scale of this program. It's already providing 17.2 GVA-seconds, GVAs, of inertia to the UK grid, and the next phase is expected to add another 26.9 GVAs. To put that in perspective, that's more than doubling the grid stability provided by these technologies. What this really suggests is that we're not just tinkering around the edges, we're fundamentally reshaping how our energy systems work. But here's where it gets even more fascinating. RWE, the company behind the Pembroke project, isn't stopping at synchronous condensers. They're also planning battery storage, carbon capture, and green hydrogen projects at the same site. If you take a step back and think about it, this is a microcosm of the future of energy, a mix of technologies working together to create a cleaner, more resilient system. What many people don't realize is that this isn't just about replacing old tech with new tech. It's about reimagining the entire system. For example, the synchronous condenser doesn't generate electricity, it's purely there to stabilize the grid. That's a fundamentally different role, and it highlights how specialized our energy infrastructure is becoming. From my perspective, this is a huge vote of confidence in the UK's ability to lead in the global energy transition. Matt McGill from NESO called this a world-leading program, and I think he's right. But it also raises a question: if this works as well as expected, how quickly will other countries adopt similar solutions? Finally, let's zoom out for a second. This isn't just about Wales or the UK, it's about the global shift toward renewable energy. As more countries move away from fossil fuels, the need for grid stability solutions like this is going to skyrocket. Personally, I think we're at the beginning of a new era in energy technology, and projects like this are the first steps into that future. So, here's my closing thought: what if this is the moment we look back on as the turning point? Not just for the UK, but for the world? It's not just about a machine in Wales, it's about the potential to redefine how we power our lives. And honestly, that's something worth paying attention to. What do you think? Is this the future of energy, or just one piece of a much bigger puzzle? Let me know in the comments below.